Hello, in this video I would like to present about one of the final project from the cloud computing course in the Asia University, teachers by Professor Jim Doan. In this presentation I would like to present what I have done in my final project about travel time interval patterns about vehicles from frequency timestamp sequences. Case study Taichung Taiwan Avenue until Holy Freeway. This TDGS Taiwan Data Collection System freeway from September 2018. Um, from this presentation, there are several aspects that important to note. In September 2018, there are 30 days, and also if you can see there are 5 Saturday and also 5 Sunday here, so the vehicle distribution will be higher on those day compared to the other day. And also in Taiwan there is one day that at 24 September 2018, this is a holiday for Taiwanese people because they have a moon festival. So I So in our assumption, there will be high distribution from maybe 21st until 24th September. And for these final projects, I choose the Taichung city in this area because there are several places that interesting to have the information. The first one in this, there are two pattern, or there are two national freeway that pass in the Titan city. The first one is National Freeway 01 here, and also National Freeway 3 here. It is also important to note there are several places that important to have this travel pattern. The first one, there is a Taichung International Airport. This one in the middle, in the center, and there are several districts like Fengyuan districts, Beitun districts, and also North district. These districts have some kind of attraction places like shopping district, mall, and so on. And on the left side, this one is Woki district and also Longling district, and I believe there is several industries lies or are in this area. And these four final projects, I just doing the two tasks. The first task is mining for regular pattern or travel time intervals from these two national freeway. And then the second one is visualization system for the statistic of TTCS travel time intervals. Like let's take one of the example from the National Freeway 1 northern direction. Northern direction, it means that we going upside from the bottom to the upside of Taiwan, from A to B. From A to B here, there are 6 gantries from Holy interchange until the Nansung interchange. This also show us the distance is around 28 until 30 kilometers in this freeway northern direction. And also we would like to investigate the southern direction from A to B here. It's also the same from the National Freeway 1. And also because in the Taichung city there are pass two National Freeway 1 and also National Freeway 2 at 3. So I would like also to investigate both of them. Okay, let's continue. This final project, I got data from the research by Professor Taiwan, and I got the data from 1 month, 3 months, and also 6 months. The detail is on my final report. And then I would like to emphasize about my workflow. The first one, the first process, I upload the gantry data that I got from the Professor Wang research. The first one, I upload the data to head of file system, and then I define the mount data intervals. In this case, I upload 1 month, that is September 2018, and then we must define the start gantry and also end gantry from southern direction and also northern direction. For this case, there are 6 gantries, and after that we process with the MapReduce framework using the window software. And then the last, if we have the result, then we show the statistic of vehicle from each pattern from National Freeway 1 and also National Freeway 3 that pass to the Taiwan. And next one, from MapReduce process, just see the video, this one. This is our MapReduce code in the window. The first step, like I already explained to you, I upload the data, 1 month data, in the DFS location, this one. I create one folder to upload all of my file, 100 file. I give a name, 1 month travel data, and then in our code I put it this one, file input format set path to point to our input data. And also for the output data, I create this one, time travel, because I point out in our code this one, output data, path HDFS, get working data, time interval. And for code itself, I using the teacher's code, TDCS MRP statistic, using window, this one, TDCS MRP main time interval statistic window. And then there are several map class and also the radius class that we can use. Take for example, in this final project, I use 3 class mapper and also 3 class reducer. The first one is the start and gantry ID mapper, and also this one as a reducer. So if you would like to use this mapper, don't forget to also use this reducer. They are in pair classes. This classes is used for if you like to count the pattern about the start and end gantry. The second one, also we would like to have the information about the vehicle distribution from start until the end of the gantry, but it based on the weekdays from the Sunday until the Saturday. And the last one, this mapper and also the reducer, is also the same. We count the information of vehicle distributions from the start until the end of gantries using the vehicle based on the vehicle type. step I'll show you the result that I have been done. The first one, if you can see, this is the graphic for the National Freeway 1. There are, from the National Freeway 1, as we can see from the graph, from the pictures, the vehicle distribution peak at 10 AM here for the north and also the south direction. The summation vehicle frequency to the north direction is greater than the southern direction. As you can see, this one, the northern direction is higher than the southern. I mean the vehicle frequency distribution. And then if we compare from the National Freeway 1 and also National Freeway 3, National Freeway 3 is busier than National Freeway 1 because the number of vehicles passed through the National Freeway 3 is 800,000 vehicles, and from National Freeway 1 is only 681 vehicles. And the other things to take a note, if we break down into a week from Sunday to Saturday, Saturday and Sunday become the two most highest vehicle distribution. And also at the 10 AM in the morning, it will become the rush hour. And Sunday afternoon at 2, it will become the highest or the most rush hour or the most traffic occur during a week. As like I told you before, I mentioned before that Saturday and Sunday there are 5 occurrences, so there will be most highest distribution on both days. And then the next thing is, if we see from the southern direction, for southern direction also the same, Saturday and Sunday become the two most highest vehicle distributions, as you can see in the pictures. The 9 o'clock will become the rush hour, and also furthermore at 4 p.m. in the Sunday it's become the highest, the peak, right? And deeper, as we can see from the vehicle type distribution, from the trailer, car or sedan, truck, bus or big truck, as we can see from the picture, the distribution most affected by 2 types of vehicles. The first one is car or sedan, and then the second one is truck, right? And it will become busier from 6 AM until 10 AM, and will reach its peak at 10 AM in the morning from the northern direction. And I believe to the southern direction is also the same. That the traffic will be increased from 6 in the morning until 10 in the morning and reach its peak from this distribution. And then more deeper, as we can see from the average travel time to the northern direction, the average travel time is around 13, maybe during the night, and ranging from 13 to 18. 18 is from the 3 o'clock in the afternoon, as you can see from the picture. And then Sunday afternoon, Sunday is the blue one, no, Sunday is the green one. Sunday afternoon from 1 p.m. until 3 p.m. it will become the traffic will increase significantly, as you can see from the pictures. And average travel time at Monday slowly increased from 9, this one, in the morning and peak at 3, uh, this one, the blue one. Okay. And the southern directions, this vehicle distribution is interesting. Why? Because from all of the day in a week, from Sunday to Saturday, um, from 6 p.m. Sorry, from 4 p.m. until the 6 p.m. will be more um, busiest, yeah, through all the day. The average travel time ranging from 12 until 25 minutes occurred at Sunday and Friday, respectively. And then Friday evening from 16 to 18, the average travel time increased significantly, as you can see this one described. And also average travel time increased from 16 to 18 in the afternoon every day from Sunday to Saturday. Okay, that's all. Thank you very much. Uh, Thank you very much for the help from our teacher, Professor Jintowan, that helped us to understand better and conduct this final project presentation and also final project activity, so I can present this video to you all. Thank you very much.